Hello everybody. So what we're going to look at today is the law of sines. So there's two of these actually. There's a law of sines and a law of cosines. I noticed that your book puts these in separate sections, and so I think I'm going to make two videos for it, but I think it's only one homework assignment. Anyway, let's go ahead and get started. So you know from the past how to find sides and angles on a triangle, right? So we already know how to find, missing sides or angles in a right triangle. Right? Stuff like this. If I give you a triangle like this, and I told you that this was a right angle, and I told you that this was like a 42-degree angle or something like that, and I said that this was 5, and I said that this was x, and I say find x, you would know how to do that, right? What you would do is you would say, well, this right here is the opposite side to that 42. This right here is the hypotenuse. We know that the sine of an angle is the opposite side over the hypotenuse, which says that the sine of 42 degrees is opposite, which is x, over hypotenuse, which is 5. And then that tells you that x is 5 times the sine of 42 degrees. And then if you punch that into your calculator, you're going to get the answer, right? So I type 5 times sine 42, and it tells me 3.35. Okay, and that's the kind of thing that you're used to doing. But the key here that you have to understand is that the only reason you can do that is because this triangle here, this triangle is a right triangle. It has a right angle right here. Okay, we wouldn't be able to do it if it was a different type of triangle, at least not with what we know. If the triangle is not a right triangle, you can't do the above work. Okay, so if I give you a problem like this, well, come on. So if I give you a problem like this where I say this is 20, and I say this angle is 15, and I say this angle is 35, and then I put x here, you can't find that with what we know now. You can't find this without what we're about to do, which is the law of sines. Okay, so I'm not going to derive the law of sines. What I'm going to do is I'm just going to have to write it down and then tell you what you can do with it. Okay, so what the law of sines is going to say is as follows. So law of sines. Okay, so here it is. So we're going to assume we have a triangle, and it's not any kind of special triangle, it's just a triangle. Okay, so we've got a triangle. We've got 3 different angles on here. I'm going to call them A, B, and C. Those are the angles. So the angles are A, B, and C. Okay, and then you've got three sides. The sides are going to be little a, little b, little c. And where we're going to draw those is opposite of the angle with the same name. So for example, you have the angle A right here. So if you go across the triangle, this side should be A. And do that for the other two as well. So B's up top, so that means little b's down here, and C's over to the right. So little c's over to the left. So this is the picture of the triangle that we're dealing with. Three sides, three angles. Okay. It doesn't matter if one of the sides is a right angle. If it is, that's fine. Okay. So, but this works even with the angles are not 90 degrees. Okay, so what does the law of sines actually say? The law of sines says this. The law of sines states there's two ways to write it, so we'll write it both ways. One way you could say sine A over A equals sine B over little b equals sine C over little c. And the other way to do it is to think about it this way. If all three of these fractions are equal, right? If this fraction is this fraction, which is this fraction, then if you flipped each of these upside down, it would still be true, right? They'd still be equal. So if you flip these upside down, what you're going to get is that A over sine A equals little b over sine B equals little c over sine C. Okay, so you just write it whichever way you want it. Basically, the way you're going to write it is whatever you're looking for, you should put on top. Because just think about what we had to do here on this sign, right? What we were looking for was the x, and it was easy to solve for it. If we had been looking for the 5, it would have been more annoying to do if the variable was in the denominator of a fraction. And so that's what we generally want to avoid. So that's why they give it to you both ways. So then you can just pick whichever one is going to be the most convenient for solving a problem. Okay, so what is it going to do for us? Let me just put a box around it and make it easier to find. Okay, put that up there, bring that down there. Okay, so there's the law of sines. And what does it do for you? Well, what it's going to do is if you know one pair of these, like an A and a sine A, or if you know a B or a sine B or a C and a sine C, if you know that, then you'd be able to find some missing stuff on the other ones. So you're going to know three things. Like maybe you know little b, little c, sine C. If you know little b, little c, sine C, you'd be able to combine those three together and find the missing b. Okay, and that's how it's going to work. You're going to know three different things, and then you're going to be able to find a fourth one. And actually, if you can find 4, you can find all of them. So let's see. You can use the law of sines. To find angles or sides in a few specific scenarios. I'll say cases, so I don't have to spell scenario. Okay, so you can use the law of sines to find angles or sides in a few specific cases, and we name them, and that's going to be helpful here. So let's see. If you know, okay, yeah, that'll work. So there's one case that we call ASA. We call it that because that stands for angle, side, angle. And that's going to be the case where you know an angle, a side, and an angle. And when we say angle, side, angle, we're specifically referring to like the order that they appear on the picture. So like when you say angle, side, angle, what that would be is something like this. Like let's say that I know that this is 40 degrees, and I know that this side is 10, and let's say I know this angle is 45 degrees. Like let's say that that's what I know. That would be an angle, side, angle, because you have an angle, a side, and then an angle in that order. Okay, so that's just an example of one. Right? We would be able to find the missing sides here and the missing angle. Another type of angle is going to be AAS. Angle, angle, side. All right. So that's just going to be same kind of thing going on, but it's an angle, a side, and an angle that you know. Sorry, an angle, and a side that you know. So what that means is when you're looking at a picture, you might know that this is 40. You don't know the bottom side this time. Maybe you know the side over here. Maybe it's still 45, I don't know. And you know this side up here instead. Like maybe that side is 8. That's angle, angle, side, because again, you have an angle, and then you have a side. Where here you have an angle, a side, and then an angle. And again, you would be able to find what you're missing. Okay. The third one is side, side, angle. Really missed an opportunity there to have an angle, angle, or angle, side, side. That's how I would have done it, right? Because then you can do that. That makes everybody happy. But no, sadly, it's the first one. So you would use this if you knew a side, and an angle. So what that would look like is something like this. If I say this is 6 and this is 8 and this is 40 degrees or something, right? Because you got a side, oh, whoa, it's like day glow color. A side, and then an angle, right? That's not what they call it. All right, so those are some of the cases that we could find. Okay, now, yeah, all right. Like I said, I'm not going to actually derive this at all, but you can't. There's a way to derive the law of sines. We're just going to use the law of sines, I think. Okay. Now, I think in the first cases are going to be easy, and then the last case is going to be the hard case. So the case where you have two angles is basically the same. So let's start there. So let's look at a angle side problem. Okay. So what's an angle side problem? So they'll give you something like this. Actually, I want to use, I just grabbed one that I made up here. That's angle side to side. Come on. Side, side, side? Kidding me. Oh well. I give up. So, you're going to know two of the things here. So what I don't like about the homework on Newton is they like to describe it by something like this. They'll say like, hold on. They'll say, in triangle FGH, okay. Oh, and they use a little triangle symbol. So in triangle FGH, they'll say something about the angles and the sides. So they'll say something like, hold on here. They'll say like F equals 50 degrees, and then they'll say H equals 30 degrees, and then they'll say, what else do I have? That's going to be, little a. No, A, which is F. Sorry. I'm trying to translate the numbers in my head here. All right. So they'll do something like this. They'll say in triangle FGH, you have this, and then they're going to want you to find a particular side or a particular angle. I'm going to find all the missing sides. So find all missing sides and angles. Right? So on your triangle, if they tell you the triangle is called FGH, they're telling you the angles. So you put FGH, it doesn't matter where you put them. And it also doesn't matter if if the numbers look like the triangle that you drew. You don't need to care about what 50 degrees looks like or what 30 degrees looks like. Just draw a triangle. So what do we know? Let's fill out what we know. So what I know is that F is 50 degrees. So that's here, that's 50. H is 30, so that's here, that's 30. And then little f is 10. Where's little f? Little f is going to be up here, right? Because it's opposite of the angle big F. So what are the missing sides, right? So like what's this side down here? If this angle is G, this side is G. So we'll go little g. And then the one up here must be little h. Okay, so you need to know what the triangle kind of looks like in terms of, not in terms of the exact shape, but what the sides are called and what the angle is called. Okay, now what we want to do is find missing sides and angles. So the first thing you want to do is realize that if you have two of the angles, you actually can calculate the third very easily. So remember, the sides in a triangle, the angles in a triangle add up to 180. So if we have a 50 and a 30, F is 50, H is 30, then G must be, you're just going to do 180 minus 50 minus 30, right, to get the missing angle. That way they'll add up to 180. So in this case, it's 100 degrees. All right, let's actually just keep track of everything here. So if I make a little table here off to the side, right, we have F, G, H, little f, little g, little h. What we knew going in was that F was 10, big F was 50 degrees, and H was 30 degrees. And then start filling in the ones that you know, or that we're finding. So we already found out that G was 100, so fill that in. And now we're just missing, you can see, the little g and the little h. Okay, so if you have two angles, get the third angle using the fact that they add up to 180. Okay, Now the next thing you have to do is we actually need to use the law of sines now. So now use law of sines. All right. So the law of sines, remember, says, well, it says a few things. So first of all, there's two forms, right? One has the angles on the top, and one has the sides on the top. And you pick whichever form has what you're looking for on top. So I'll pick the second form because on this problem, I've already got the angles. I'm looking for the sides. So A over sine A, B over sine B, C over sine C. So use the law of sines. But ours are not called ABC, they're called FGH. So the law of sines for us actually looks like this. F over sine F equals G over sine G, not little g, big G, H over sine H. So this is what it looks like for us, right? And then what you do is you don't need the whole thing at once. You just need 2 out of the 3. So what you're going to do is you're going to say, oh, okay, so first of all, I have the big F and the little f, right? So what am I looking for first? Let's look for the little g. So if I'm looking for the little g, which is right here, then the angle that goes with it is this one over here. So I should write out the part of the sine and the cosine that uses just the f and the g. So what I want to do is use this. I'm going to use f over sine f equals little g over sine g. So you don't use the whole thing, just 2 parts. One of the parts has to be the one that you know at least 2 things from. Not at least 2 things. Where you know the angle and the side that go together. And then the other one has just one missing. Okay, so we'll use that. So we use this form, and then what you're going to do is you're going to plug in your numbers now. For the f's and the g's. Variables. All right, so what's that look like? Well, we've got little f, which I know is 10, right? I'm just reading them off here. So little f is 10, big F is 50 degrees, equals little g, we don't know little g, so you just leave it little g, over sine g, which is sine 100 degrees. Okay, now I don't know how many decimal places you're going to need to calculate these two. It looks like they do it exactly, so we should maybe be careful. Actually, no, they can't do that exactly. They must be using decimals. Hold on. Okay. Okay, give me a good question, guys. Yeah, okay, I mean, they're rounding to the nearest tenth. But anyway, so you plug in your numbers, right? You can calculate this now. What I like to do is if you're trying to save as much accuracy as possible, then what you want to do is not put it into your calculator yet. You want to just solve for g. So if I solve for g, then all I would have to do is take this equation here and just multiply the left side by sine 100 and then multiply the right side by sine 100. And then what I'm going to get is simply g is equal to sine 100 degrees times 10 over sine 50 degrees. And then you just put that into a calculator and that's going to give you your number. So let's do that. So we've got, oh, that did not go big. Hold on. No. It's impossible. Sorry, I'm fighting with an iPad right now. Okay, there we go. All right, so we're trying to do this. Sine 100 times 10 over sine 50. So make sure you're in degree mode. I'm in degree mode. Terrible things are happening on the screen. Delete, delete, delete. Okay, so I'm in degree mode. So all I want to do is I just want to do sine 100 degrees times 10 over sine 50 degrees. Enter. 12.855. Now you only have to round to the nearest tenth, so probably on the calculator or probably on Newton I'd be typing in 12.9. But there you go, that's it. So we found one missing thing. So we found one of the missing ones, so we come up here and you go 12.9. All right. I'm going to say, what did we do? We used law of sines to find g is what we did. Now we also need h. So next thing, we're going to use the law of sines again. To find h. So law of sines to find h. Now you need to use two of these again. Okay. Now technically, if we're trying to find h, then what we're going to be doing is we're going to need to use h, obviously, because we're looking for h. Now, for the other variable, we could either use f or g. Now, we could use g, but the problem with using g is this. Like, so let's say I'm going to write out this, and I'm going to use h, and let's say I decide to use g. So this is the part that I'm going to use. The problem with that is if I'm going to do this, then I'm going to be relying on this g, right? The 12.9. The 12.9 was something that I calculated. I calculated it, and I might be wrong. So I would rather not use the g. I would rather use the f, because the f was given in the problem, right? Those numbers on top I didn't come up with, so I know that they're right. So I would prefer to use the f and the h, because then I'm not relying on my own numbers, I'm using their numbers. So we use the law of sines. I'm going to use what version? We're missing a little h. So how about f over sine f equals h over sine h, like that. Okay, that's what we're going to do. So that's the one we're going to use. We're going to plug in our numbers. So we plug in our numbers. What numbers? So my numbers are, what's f? Oh, right there, 10. Little f is 10, big F is 50. So that's 10 over sine 50 equals little h, we don't know it, over sine h, big H is 30. Big H is 30 degrees. All right, so you put in your numbers, solve for h. So the little h is going to be, you bring the 30 up, it's going to be sine 30 times 10, so times over sine 50. So you go back to a calculator. We got sine 30 times 10 divided by sine 50. Enter. 6.5. 6.53. Which again, I think we have to round, so probably 6.5 is what ends up being typed into Newton, if this was a Newton problem, which it's not actually. Was it 6.5? Yeah, 6.5. Okay, so that's it. So I've got all of the sides and the angles now. Okay, and that's done because we have all the sides and all of the angles. All right, and so that's how you do these basically. Now, they're not all this easy though, because sometimes you have to think about an answer, and so we're going to see that in a minute. Oops, that's not what I wanted. Okay. So what was that? That was angle side. No, that was angle side, wasn't it? Let's do another one. Let's do a example. And what was the other one that had two angles? What did we just do? We just did angle side. Let's do angle side angle. Let's do angle side angle. Okay, angle side angle. See if I can find an example. If not, I'll just make one up. Nope, there's angle side angle. Okay, excellent. So here's what they give me. They give me a nice picture here, so I'm going to write it. Sometimes you have a picture, sometimes you don't. So, you know, if they give you one, use it. If they don't give you one, that's fine. All right, so it looks like this. They say that this is 58. This is 17. This is 7. This side is little c. This side is little b. This is angle A. This is angle C. And this is angle B. Okay, so everything's labeled except this is A. Okay, so to keep track of our stuff, let's just make a little box for it. So I know I have an A, a B, a C. I have a big A, a big B, a big C. And we know some of this. What do we know? We know little a is 7. We know big B is 17 degrees. We know big C is 58 degrees. So this is what we're starting with. Notice you always start out with 3 out of the 6 here. Okay, so let's go ahead and get started. So very similar to the previous one, because you know 2 of the sides, you know 2 of the angles, you can definitely calculate the third. So since we know 2 angles, we calculate the third. Right? How do we do that? We know they add up to 180. Okay, so let's do that. So what do we know? We're looking for A, right? So A has to be 180, and then we're going to subtract the 2 that we already know from 180. So minus 17 minus 58. So you grab a calculator. I'm just going to do that on my calculator. I'm not going to bring up the calculator. 180 minus 17 minus 58. 105 degrees. All right. So you found something. So let's put it in. 105. Okay, so far so good. Okay, now what we need to do is we're looking for the little b or the little c. Look for, which should we do? Let's just do the b right now. It doesn't matter. Look for b using the law of sines. All right, so if we're looking for b using the law of sines, what are we going to use? We're going to need to use the a, because that's the one where we know 2 of the things. And we're going to need to use b, because that's what we're solving for right now is b. So we're going to use the part of the law of sines that has a and b. So we're going to use we are going to use this. A over sine A equals B over sine B, right? We don't need the C over sine C part right now. So we write that out. Put in your numbers now. Put in numbers. So what do we know? Little a is 7. Big A is 105. Now remember when I said we don't like to rely on the numbers that we came up with? That's true, but I don't have a choice, right? We have to use that 105. But also, I'm pretty sure it's right, so it's okay. Now we got B. Little b we don't know, so put in a little b. And then big B is 17. So over sine 17 degrees. So if we're looking for B, B is, you're going to bring the 17 up, sine 17 degrees times 7 over sine 105. This is multiplied. All right. So B is what? Well, we just punch this into a calculator again, just like we've done twice now. So we just clear this out. What do we have? Sine 17 times 7 over sine 105 close parentheses. We got 2.1. I'm just going to round it right now because I can see on the picture there that they've got it rounded to 1 decimal. So B is 2.1. All right. So B is 2.1. We got it. So there you go. Let's go put it up here. We got that. Okay, now we're looking for C. So if we're looking for C, we're going to need to be, using this part. And should we use the A's or the B's? I'm going to use the A's. Now, technically, 105 we came up with, it could be wrong. And little b we came up with, and it could be wrong. But what I'm actually worried about here is not that this is wrong, because this isn't wrong, this is right. But we rounded it, remember? We had to round this number, whereas the 105 was not rounded at all. So I would still rather use the A's than the B's to base my calculations on, because this is a rounded number, and that rounding might make a difference in calculating the missing C. And if we make a mistake there, we could just be off by a little bit, right? Like the answer could be like 7, and we'll type in 7.1 and get it wrong. So try to use the ones that are not rounded and the ones that they gave you, not the ones you came up with. So little c. So we're going to use A's and C's. That's what it comes down to. So let's do this. So now we're going to find little c with law of sines. So little c over sine c equals little a over sine a. I don't know why I put the c first. It doesn't matter though, right? So that's what we're going to use. Let's plug in numbers. I guess I'll actually do it over here. Little c, what's that? That's what we're looking for. We don't have little c. What's big C? We have big C. 58 equals little a. What's little a? 7 and 105. So 7, 105. Okay. So there you go. We're looking for C. So, we'll bring the sine 58 up this time. And I'll just write it right here. When we have an answer. So what do we have? 7 times sine 58, close over sine 105, close, enter. What do we get? We get 6.1. And notice that it's actually like 1.45. That's actually really close to being 6.2, right? It's really close to being rounded up to 6.2. So if we had used the b's, the fact that we rounded that b to 2.1 may have made the difference, and we might have calculated this, and instead of getting 6.1, we might have gotten 6.2, and it would have been just because the number that we used was not completely accurate because we rounded it. So, okay, so there we go. So we have the C, and that's it, we're done. So what did we do? We found all of the answers there. What was it, 6.1? All right. So, yeah, that's how it goes. However, there's another case that we have not considered yet. And so the case that we have not considered yet on our triangles here was we did ASA, we did AAS, we did not do ASS, SSA. That's the one we didn't do. Okay, so we need to look at that one. And that one's actually a little bit trickier because if you think about it, look at the picture. You only know one angle. So if you only know one angle, then you've got to calculate the other angles using the law of sines, and that's different than what we've been doing up until now. Okay, so let's we need to talk about that a little bit. So SSA triangles. Okay, so I'm going to draw a picture for you. This is not an example. We can't just jump straight into doing an example here because there's actually several cases here. So the problem with these, it makes them trickier. These are trickier because depending on the numbers that you have, there are different outcomes. So what can happen is they could give you, so let's say they give you, what are they giving you? SSA. So what are we assuming we know here? Okay, well that's kind of annoying here. So I'll just draw the pictures. So one case is going to be where there's no triangle. So they could actually give you numbers now where there is no triangle that actually matches up to the information that you're given. So it's like they told you there was a triangle and there's actually no triangle. So the reason there would be no triangle is you'd have one side that's too short to make a triangle, right? Now, in another case, there's just going to be, you might get a right triangle, which actually is fine. Don't really know why I'm drawing this, but they said to, so I'm drawing it. Okay, so you just get a triangle, that's fine. A third thing that can happen is, so when you're looking for an angle, that there's actually, so like let's say you have this side and you know that side, they give you the number. And then let's say you have another side, and how do I want to do this? I want to draw this like, yeah, right there. Do I? Yeah. So, I'm just extending that side out. Now what happens is there's actually, you know this angle. So what you know is this. They tell you this angle. and they tell you this side. So like this is, let's say that's A. So you know angle A, and then you know side B, and then let's say you know side A. And so side A is going to be, from this corner. And so what happens is side A might be here, but also side A might be here. And there's no way to tell, because if this is side A and this is side A, then the two triangles that I just drew, so there's this one, well, I can't, I'm having trouble drawing it here, hold on. So this one has an A that you know, a B that you know, and a little a that you know. So it is side-side angle, whereas the other one, the is like this, and the angle can still be the same, the B can be the same, and the A can be the same, and it's still a completely different triangle. So you have two triangles that actually match the information that they give you. So two triangles match. I wrote two, like it's just too much triangle. Two triangles match the information that they gave you. All right. So that's a case. And then the third case is just kind of the normal case where there's just one triangle. So all right. So yeah, so you've got one triangle there, and you've got one triangle there, and they're obviously different triangles, but A, B, and big A are all the same. So that's what can happen. Okay, so what we need to do is we need to talk about that. So they call this case right here the ambiguous case, which we'll get to. All right, so let's look at it. All right. So let me think here. All right, sorry about that. Yeah, so let's look at this. Okay. So I think it's hard to, I can't really do this without an example. So we're going to do an example now, and let's look at it. So example. So let's say in ABC, triangle ABC, A is 45, little a is 30, little c is 23. Okay, and what I want to do is I want to look at, I just want to solve the triangle. That's not how they actually ask it in the Newton, but I'm just saying solve the triangle, just like the ones that we did earlier. Solve the triangle. All right, so what am I doing? So we have A, come on, A, B, C, big A, big B, big C. We know that big A is 45, little a is 30, little c is 23. All right, so this is what we know. Okay. So let's try to draw that triangle. Now, again, I don't actually know what's going on here. So if you draw it, you've got big A, which is 45. You've got little a, which is over here, 30. We have C, so so this is B, this is C, so this is little b, and then this is little c, which is 23. Okay, so there's my picture. Now my picture might not be accurate because there's multiple cases, right? But this is what I'm going with so far. So here's what you would do. So first of all, the issue is that you're missing two sides of the triangle. So if I'm going to use the law of sines, which I am, I'm going to use this side, or the A's, right? Because I know both of those, and I need to find the big C first. Okay, I need to find the big C first. So you're going to use the law of sines. To find the big C. Okay, and this is where there's going to be cases involved where we have to think about it harder. So we're going to be using A and C. Now, remember how we talked about how law of sines, you could use it either right side up or upside down here. So we've been using we've been using these, right? Because we were missing sides. But if you're missing an angle, which we are, then it makes sense to use the top formulas because the angles are on top. All right, so we'll use that form. So back down here. Where are we? All right, so use law of sines to find C. So we're using A and C. So we want, come on now. We want sine A over little a equals sine C over little c. Okay, so fill in your numbers. So far it shouldn't feel that different. So we fill in the numbers. So we have sine 45 degrees over little a, which is 30, equals sine big C, which we don't know, over little c, which we do, is 23, not 22. 23. Okay, so this will tell you that sine C is equal to, you bring up the 23 times sine 45 over 30. Now I'm going to do this a little bit differently than before. I'm going to work out that fraction on the left. Come on, calculator. That's not what I wanted. Nope. Where'd it go? There. Okay, there we go. So let's just put in 23 times sine 45, parentheses, over 30, enter. And so what I get is this. I get 0.54212, something like that. I just want to use enough decimals that it's not going to be an issue later on. Okay, so we have that. Now, that's sine C. So you actually have to do an inverse sine to get the C. So that's new. We haven't had to do that before. So this is going to say C is going to be equal to sine inverse of this number here. All right, so back to the calculator. Never. Sine inverse 0.54212. enter, go. Okay, so this is degrees, right? So this is 32.8. Yeah, that's fine. Okay. So it would be really nice if this was actually C. Okay? And I think it actually is in this problem, but you don't actually know that. So this is where you get problems. So I think what we just did, the last step was a little bit new, but mostly it should make sense, right? So the big problem with this is that C might not be correct. All right, so what you have to do is come back up here and say this C might not be correct. Right? So how would you know? How will you know if it's correct or if it's allowed to be correct? So what you have to do is you have to say, well, it might be, I'm trying to get a different color here. It might be C equals 32.8. That's what we just came up with. Or the other possibility is that C is going to be 180 minus the 32.8, which is, what is that? 180 minus 32.8, which is 147.2. Okay, so you get two different possibilities here. Okay, you've got, let me actually write the C in again. So you have one possibility for C and you have a second possibility for C. Now, why is that the case? Well, that's the case because that's going to be the case where there's two triangles, right? If there's two different triangles, the thing that's different about them is the angle right here is a different angle. So that would be like the 32 and the 147. However, I say the C might not be correct, but these are not necessarily both allowed. But let's get into that in a second. Let me bring the calculator up. That's what I'm trying to do. Okay. So just to see why that this is allowed, watch this. If I do sine 32.8, what do I get? 0.54, right? 0.54. Now what if I do sine 147.2? Same number, right? 0.54. So they both have, like, those angles both have the same sine value, and that's why they might, either one of them might be correct. Now, you don't have to think very hard about this, right? You just do 180 minus whatever the answer is, and then that's your second one. So you actually get two different C values. Now, what you have to do then is you have to figure out whether or not they both are valid answers. Okay? So what you have to do after all this is I'm going to check if both C values are going to work. Okay? Now, how are we going to do that? Well, basically all you have to do is just think about the triangle that they would give you. So look at the triangles. Each C value would give you. All right, so I've got two different triangles that I'm going to draw. So what I got, oh, it's so laggy right now. So if I do, what was one of them? One of them was C equals 32.8, right? So if I draw, I don't have a triangle, I'm going to just draw a triangle. That's an ugly triangle. All right, let me draw on the numbers here. So, oh man, it's killing me here. Oh, wait, hold on. I'm unhappy with what's going on here. It's too laggy, first of all, so let me close it and open it. Open it up again. Okay, good. Let me just copy this. Duplicate. Bring it down here. All right. So on one of them, we've just determined that C, all right, so this is like this. Okay. So one of them is C equals 32.8, right? So that means that this right here is 32.8. So if this is your triangle here, 45 and 32.8, if A is 45, right, that was given in the problem, then what would B be? B would be 180 minus 32.8. Minus 45, which is, take a calculator, 180 minus 32.8 minus 45, you would get 102.2. Does that make sense? So you have a C, you have an A, and if that was your C and your A, this would be the B that you get. Now your other possibility was that C was, what was the other choice? 147.2. And again, I'm not really going to do too much here. So you had 23 here, that was little c. B, A, that was 45. This we just came up with, this was 30. All right, and so what we're saying is that this is 147.2. Now, there's going to be a problem right here. C was 147.2. A was given in the problem as 45 degrees. And so the B would be 180, right? Because they have to add up to 180. 180 minus 45 minus 147.2. So the B would have to be 180 minus 45 minus 147.2, negative 12. Well, how could that happen? Right? How could you have 147.2 for one angle, 45 for another angle, and one of the angles is negative 12 degrees? That can't happen, right? That can't happen. You can't have a negative angle. So that's what happens here. No. You can't have negative angle. B. So do you see? What you do is when you get these two, you calculate two different angles for C, the one that you calculate and then 180 minus that, those are your two C values, and then you just draw the triangles, but when you try to deal with them, one of them might be bad. Now, I say might because this doesn't always happen. Sometimes you just get two triangles, okay? So what do we determine from this? What we determine from this is that second triangle is not valid at all. So that's what you determine. So the second triangle is not valid, right? So once you know that, you can just say, not this. Okay? Second triangle is not valid. Now, once you do that, then you just go back and you start calculating whatever you're missing now. So we have one good triangle. So you come back up here and you say, well, what did we just find? C is 32.8. What else did we find? B is 102.2. All right. And so now all we're missing is the little b. So last step here. So find little b with the law of sines. So what is it? It's going to be b over sine b equals, which ones do we want to use? A. A over sine A. So fill in your numbers, right? This part's really easy. So the little b, we don't know. But we do know 102.2 equals A. What's A? 30? 30 and 45 degrees. All right. So you solve for B. B is 30 sine 102.2 over sine 45. B is 30 times sine 102.2 over sine 45. 41.5. Okay. If I did that right. It was 102.2, right? Is that correct? Yeah. Okay. So what did we get? 41.5. All right. So while we were doing that, it occurred to me that probably the smarter thing to do would have been when I came up with these right here, when I came up with this one and this one for the C, I probably should have just made a second one of these tables, and we could have just filled out the second table there. That would have been smarter. I think I'm going to do that on the next example. So hopefully the next example is more easier to understand. Let's try one. Okay. Oh, by the way, just in terms of Newton, we had two triangles, right? We got two angles, 32 and 147. We drew two triangles. We had to throw out one of the triangles, right? So the triangle that we had left was the one on the left, right? The actual question on Newton said a weird thing. The actual question on Newton was this. It said, what is, or what best describes angle C. That's what they actually say on Newton. And the choices were it's acute, it's obtuse. Now remember, acute means less than 90. Obtuse means, greater than 90. Both acute and obtuse, or C doesn't exist, or no triangle, I should say. So those were the choices, and the correct answer was what? Well, what did we get for C? We got this C, right? 32.8. What is that? That is an acute angle. Okay, so they didn't actually ask you to solve the triangle. They asked for something else, which was weird. All right, let's try a different one. That's too easy. Okay, another one, just the same, different numbers. Okay, cool. This is exactly what I wanted. ABC, A is 47 degrees, little a is 23, little c is 26, and again, they want what best describes angle C. Okay, and so describes. So let us let's do this. So I'll make a little table here. Well, no, I'll write it like this. We have little a equals, little b equals, little c equals, big A equals, big B equals, big C equals. We know big A is 47, little a is 23, little c is 26. So this is what we know. And I'm going to put that in a box. Okay. And then here's what I'm going to do. I'm going to copy this box and I'm going to put it over here. So this is going to be, if we end up with two choices, right? So this is going to be, you know, for the first C value, and this is going to be for the second C value, right? So we'll try to fill out both of these as we go. Okay, so let's try to do that. So what do we do first? So we've got we have A, and we've got part of C. So we need to find C. So step one, find C with law of sines. All right. So we're going to use C and A. So we have sine big C over little c equals sine big A over little a. Fill in the numbers. So we've got sine big C we don't know. Little c we know is 26. Sine A is sine 47. Little a is 23. So that tells me that sine C is going to be 26 sine 47 over 23. So we have sine C is, well, we got to calculate it, right? All right, so let us calculate that. So we got, nope, no, cancel. (26 sine 47 over 23). Go. 0.82 6 7. Okay. Now, remember how to do this. Once you have the sine, that means that the C is sine inverse of this number, which is, right? So you have to do sine inverse of this, which I'll type it in again. So shift sine inverse 0.8267, go. 55.8. Okay, so we did that. Now what you have to remember is that in this case there's two choices. So you've got your choices now. There are two C values. One is the one we just calculated. Okay. The other one is C equals 180 minus the number you just calculated. So 180 I'm not going to bring up the big calculator. 180 minus 55.8. I get 124.2. That's my other one. All right. So instead of going straight to a triangle, I'm going to take those numbers and I'm going to put them up here. And I've got two choices, right? The one from my first triangle is 55.8. The second C value is 124.2. So these are my two choices here. So I have two different choices here. And then what you have to do is, in order to see if they're okay, you just need to calculate the B and just make sure that B is not negative, basically. So so I called that step 2, check if both C values work. So I'm going to say calculate the B to see if both C values work. That's how we'll do it. So compute B for both angles, both triangles, to see if they're both okay or not. Two triangles or one. So what do we have? So we're doing this for each one. So on my first triangle, I've got my angles are 47 and 55.8. So first, what was it? A was, I already forgot it. Come on now, 47 and 55.8. Right? So if those are your angles, then the B is 180 minus 47 minus 55.8, right? So what's the B? Grab a calculator. 180 minus 47 minus 55.8, which is 77.2. All right, that's fine. So come up here, 77.2. That's fine. Now what about the other one? What about over here? So 47 and 124.2. 124.2. Okay, right there. All right, so these are my angles. So on my second triangle here, my B is 180 minus 47 minus 124.2. So grab a calculator and do that. 180 minus 47 minus 124.2, which is 8.8. Positive 8.8. So actually both of these are allowed, right? That's allowed. That's an allowed angle. So is this. Why is it allowed? It's not negative, right? That's all we were worried about. Not negative. 8.8 is fine. It's just a little skinny angle. Okay, but it's an angle nonetheless. Okay, so there you go. So all we're missing now is the B, right? If you wanted to finish this problem, what are we missing? Just the little B, right? If you wanted to continue on with this problem, what you would do is, since there are two triangles, you would have to find the B separately for each one, because there's actually two triangles. Because your choices are, let's see here. I need to just cut this out. Hold on. I didn't want to take all that stuff. Hold on. Try again. right? So if this is the information that you have, right, then what you're looking at is a triangle where you've got, okay, that's a little tiny one, hold on. All right, it's hard to draw, but if this is 47 degrees, okay, and then on this one, where's the C? Did I draw the picture on the last one? Hold on. A, B, C. A, B, C. Okay. So what you have is like on this one, it's something like this, where you have the 47 where I drew it. This is supposed to be 77, which is not. I didn't draw it big enough. And then this is 55.8. Okay. So that's that triangle. And then so what happens over here is that if this is A, this is B, and then this is C, is that the side B here has to be really, really small. So hold on, let me figure this out. So according to this, B is really, really teeny. Because this is only 8.8. Can't even read that. Okay. But A is supposed to be 47. Well, how is that even going to happen? Okay. Sorry, this is just tricky to draw. It's something weird like this, where this angle is 124.2, and this angle in this corner is 47 degrees still. So it's kind of it's a weird one. And so somehow they both have the same sides A and C. So like if the A here was 23, then the A here is 23. And if the C over here is 26, then the C over here is 26. So do you see how like the two sides that I labeled in green and this angle, like those could be the same, but then the rest of the triangle is completely different. And that's what happens here. So if you wanted to, you would have to find the B, which is, this is the B, this is the B, separately in each case, which we can do. They don't ask for it, but we could do that. So let's just do that. I mean, why not? We already come this far, right? So if I want to try to find the B here, I would use like B over sine B, and then I'll use A over sine A. And you put in your numbers, which are, we don't know B. We do know the angle B. We do know little a. We do know big A. Like that. And then this tells me that B is going to be 23. I'll bring this sine up to the other side. Sine 77.2 over sine 47. I'm not going to do that yet. I'm going to just put in equals, and we'll do it in a second. And this one over here, if you did the same thing, you don't need to do it at the same time. But like that, and then B over sine B, but what's B? This time 8.8. different number. And then A, 23, over sine 47. And then so on this one, B is equal to 23 sine 8.8 over sine 47. So you have these two, and you know, this is going to give me one answer for B, and then this is going to give me a second answer for B, and it's just because there's just two different triangles. So if we go to a calculator, and you just calculate them. So 23 times sine 77.2, enter. This one gives me 22.4 for little b. And that's about right. Like, you know, I mean, I didn't draw a really good triangle, but B was relatively big here. Should have been around the size of the other ones. And let's calculate the B on this one. Notice that from the picture I drew, B should be really small. So I expect it to be small. 23 times sine 8.8 over sine 47, enter, 4.8. Okay. All right, so those are my two triangles. Now, actually, what the question said to do was to, you know, which of these statements best describes the angle C. And again, my choices were similar or the same as the previous one, right? The choices were acute, obtuse, acute and obtuse, and no triangle. Okay. And so what was it? Well, we actually did get two different triangles, didn't we? So actually this is the correct answer. That's the two triangle answer. Okay. So I think we're just about done with this. Okay. So there is one more case though. So something we haven't seen is the no triangle case. So I'm going to show you what the no triangle case looks like. So this is our last example because this is a long lecture so far. Whoa, really long lecture. Example. Let's see. Triangle ABC has angle C is 56, little c 17, little b 27, and they say how many triangles such triangles are there. Now we've already seen that you can get one or two, right? The last one had two and the one before that had one. So this says how many such triangles. So you don't do anything different. We do exactly what we tried to do before. So we are going to, oh well, let's actually put our information in a graph, a little picture, right? It's a lot easier to do these when you do like A, B, C, A, B, C, where you can look at what you know and what you don't. So we know that this is 56, and this is 17, and this is 27. All right, so this is what we know. All right, so the first thing we're going to have to do is we know the C. We do not know the big B, but we know the little b. So we're going to have to use the B and the C to find little b. So that's how we'll start. We're going to, step one, find B with law of sines. All right, so since we're looking for an angle, we'll use the form with the angle on top. We need to use B and C because those are the numbers that we have, like that. So you write it out. You plug in your numbers. So your numbers are big B, we don't know. Little b, 27. Big C, 56 degrees. Little c, 17. So this tells me that sine B is bring the 27, right? Bring the 20, ooh, that's not what I wanted. Bring the 27 on up to the other side. You're going to get 27 sine 56 degrees over 17. So you get sine B. We punch this into a calculator, just as we have done twice now. 27 times sine 56 close over 17. And you get 1.3167. Now you may see what the problem is already. If you don't, you're going to see it right now. So if you're trying to solve for B, what did we do? We do B equals sine inverse of this answer. Right? So you go sine inverse 1.3167. Enter. Math error. Right? It gives me an error. And that's going to happen on a pocket calculator too. You're going to get an error when you try to do that. So you try to do it and you get error. Right? You get error. Why do you get an error? The reason you get an error is, remember what the sine function looks like. The sine function, if you look at a graph of the sine function, is like this, between 1 and -1. It can never be 1.3. That's not a valid sine value. So you can't take the inverse sine of that. It's just not a valid number. Okay? So that's what the issue is. So let's say that. Sine inverse of bigger than 1 doesn't exist. I don't know why I wrote right up to the edge like that. Hold on, let me. Okay, so that doesn't exist. You get an error on your calculator. All right, now when that happens, the reason that happens is you're in the case where there's no triangle here. You're in this case. They gave you numbers that didn't work. Like they gave you that this is 56. And then they gave you that, what is it? Like this is 27. And then they give you that this side is 17. And 17 isn't long enough for this to reach all the way down to that other side. So that's what happens. And the way you know that there's a problem is when you try to find the triangle, you just literally can't. You get a math error. Okay, so that's it. When you get an error like this, that means you're in the case where there is no such triangle. So math error means there is no triangle. With the numbers they gave you. and that's it. Okay, so those are, actually easy. You're kind of hoping that you get one with no triangle because you finish it quicker. All right, so that's it for this lecture. We're at 135, very long lecture, and we still haven't talked about law of cosines. So something you'll be happy about for law of cosines is that there's no funny business with law of cosines. Plug and chug basically. So anyway, let's hit stop, and I'll do another lecture on this stuff later.